In this video, we will talk about full screen outlines in Unity. Again, because my previous take was not good enough. It simply breaks apart in a more complex scene. So in this video, instead of coming up with my own solution, I will use an established edge detection technique like Sobel filter, Scharr, Roberts cross, etc. For the tutorial, I'm using Unity 6 and my project is set up in URP. So from the asset store, I've downloaded a basic interior pack by Unity Technologies and it has this nice scene. Now first let's create a shader. So create shader graph URP and then select full screen shader graph. And I'm going to call it outlines. Then we need material for our shaders, so let's create a material for that. Again, I'm going to call it outlines. Then to apply this material, select your renderer asset and then hit add render feature. Then select full screen pass render feature. Then in this pass material slot, let's apply our newly created material. And I'm going to select the inject point before rendering post-processing. And if you've never created a full screen shader before, I have an entire video about it where I've talked about all of this in much more details. You should definitely check it out. Then in the shader graph, open up the graph inspector and in the graph setting, set the blend mode to alpha, otherwise this alpha block won't work. Now here I will implement an edge detection technique to find discontinuities in our scene. We can find discontinuities in many different ways, like based on the color data, based on normals, based on depth values, etc. And the operator I'm going to use is known as Scharr operator. And to understand it better, let's first talk about some theory. Scharr operators are simply 3x3 kernels, one for horizontal axis and one for vertical axis. Then let's say we have our depth texture and we are currently evaluating for this pixel. So we will take our horizontal kernel, put it on top of our depth texture like this. Then we will evaluate for this pixel. So basically we will read the depth value and multiply it with our kernel value. And we will do the same thing for all 9 pixels and add the results together. This will be our horizontal gradient. We will call it gx. Then we will take the vertical kernel and again repeat the same process. And this time we will call the value gy for vertical gradient. Then to calculate the actual gradient, we will simply use good old Pythagoras. And of course, we will repeat the same process for every pixel on our screen. Then to get the outlines, we will simply evaluate our gradient value against some threshold. And this technique is a lot similar to Gaussian blur. Unfortunately, I don't have a detailed theory video on either of those topics, so if you wish to learn more, I can recommend Captain Disillusion's blur video. Alright, now here I'm going to write some code. And due to that, I was really conflicted on whether to go for shader graph or just completely write the custom shader. I've decided to stick with shader graph because in my opinion it would be easier to understand for beginners, especially if you don't have any prior experience in writing shaders, because Unity's documentation for the topic lacks severely. Alright, now first I'm going to create an HLSL file. I'm going to also call it outlines and I'll change the extension to HLSL. Now in the HLSL file, first I'm going to define a structure which will contain both our horizontal and vertical kernels so that we can access them easily. So I'll go struct, then let's call it Scharr operators. And then here I will go matrix 3x3, so float 3x3. Let's call it x and one more for the y. Then our kernels will look like this. So let me define a method to initialize them. So first it will return our structure. So Scharr operators. Then I'll call the method get edge detection kernels, and it won't take any parameters. And here I'll go Scharr operator kernels, then kernel.x equals flow 3 by 3. And in GLSL and HLSL both, matrices are defined in column major order. So for our horizontal kernel, the first column is -3, -10, -3. So I'll go -3, -10, -3, then 0, 0, 0, then 3, 10, 3. And our vertical kernel is just the transpose of our horizontal kernel. So the first column is the first row for that. Second column, second row, third column, third row. So I could write kernels.y equals transpose of kernels.x. And it would work just fine. But in Shaderland, if you already know the value of a variable and it won't going to change, it is a good idea to hard code that to avoid any extra calculation to save any kind of performance. Of course, GPUs are a beast nowadays, but still, it's generally a good practice to follow. So again, I'm going to hard code the vertical kernel as well. So 3 by 3, and the first column is -3, 0, 3. Then second column -10, 0, 10. Third column -3, 0, 3. And now that we have our kernels initialized, let's return our structure. Just like that. And now it's time to implement our actual edge detection logic to find discontinuities in our scene. We can find discontinuities many ways, like with scene color, scene normals, depth texture. But let's use depth texture for now. So I'm going to go void, then I'll call the method depth based outlines, and I will use this method as my custom function node. So I also have to specify this precision, so underscore float, and it will take two input parameters, first being screen UV, so float 2 screen UV, and another float 2 for pixel size. Then the function will output outlines as float, so I'll go out float outlines. Now here, let's first get our kernels. So Scharr operator kernels equals get edge detection kernels. Then I will specify my horizontal gradient, so float gx equals 0. And same thing for vertical gradient, so float gy equals 0. And now for my current pixel, I need to evaluate the depth value for all adjacent pixels. So I'm going to write two for loops. For int I equals -1, I less than equals 1, I plus plus, and one more with j. And now if we take a look at our kernels, for middle pixel, it will be 0 for both kernels. Anything multiplied with 0 will be 0, so I can safely skip one iteration. So I will go if I and j both are 0, then I need to simply skip the iteration, so continue. Then I'll define an offset, so float 2 offset equals float 2 of I and j, multiply with our pixel size. Now I can read the depth value, so float d for depth equals sample scene depth with screen UV plus offset. Now I have this error because this function is not a built-in function. I'm going to fix that in a bit, but first let's go our horizontal gradient plus equals our depth multiply our horizontal kernel, and then go I plus 1 and j plus 1, because index starts with 0 and not the -1. And again, This index is for our column and this index is for our row. Then same thing for the vertical gradient, gy equals depth into kernel y. Then outside the loop, let's calculate our actual gradient. So float g equals good old Pythagoras, so square root of gx squared plus gy squared. And now for the outlines, I can evaluate the g value against some threshold. So if g value is greater than that threshold, I want 1 value, otherwise I want 0. So I can simply go outlines equal step function, and let's try 0.02 and pass in the g. Alright, now it's time to fix this error. And as I mentioned earlier, this is not a built-in method. It is defined in declare depth texture.hlsl file, that too under the Unity declare depth texture included keyword. So I have to wrap this entire thing with hash if defined, then Unity declare depth texture included, and then here I'll go hash and if. And this is called a conditional compilation. So Unity might go that, hey, you are not returning the outline values for every possible path. So before I do all of this, I'm simply going to initialize my outline values with 0. Then in our shader, let's create a custom function node. Open up the graph inspector. Then this custom function needs 2 input parameters, so let's define them. First being screen UV, it will be of type vector2, and another vector2 pixel size. Then it will output float value, let's call it outlines. Then set the type to file, and for the source let's select our HLSL file. And for the function name, I have to write the exact name of my method, excluding that precision. So depth based outlines. And now we have our own custom function. Pretty cool. Now let's define both this input. So first let me create screen position node. It will be our screen UVs. Now this pixel size is basically our outline thickness, and obviously I want to access that from the inspector, so let me create a new float property. Let me call it outline thickness, and I messed up the spelling, and let me set the mode to slider that goes from 0 to 3, and let me set the default value to 1. Drag it in. Now I need to convert this outline thickness value to pixels, and I can do that by simply dividing it with my screen resolution. So I'll go divide, then I will divide it with my screen resolution, so I can use screen node. I can access width and height. Let's combine them in vector2 and use it in the divide node. Alright, now we have the pixel size here. Let's feed it here, and let's visualize our outlines. And now I have that base outline, but there's one issue. Like for example, this plant. So for this leaf fragment and this table fragment, there's not much depth difference, so I'm not getting the outline here. Same thing with this floor and this vase. You can of course mitigate the issue by playing around with the threshold value in the step function, but still depth-based outline has its own issues. So let's try to create the outlines based on scene normals. Alright, now I can basically copy paste this function, but I'm going to write it by hand so that you have some time to figure out what is going on. Now I'm not calling you slow, by the way. It's just that in any tutorial, if the tutor copy paste and tweaks some code, it is actually hard to follow and put a lot of us off, including myself. So I'm going to write the new function. So here I will go void, this time normal based outlines. And again, the float precision will be float, so 32-bit float precision, then same input parameters and output parameters. Then here again, let's grab our kernel, so like this. Then let's define our gradients, then loops, and writer is pretty fast. Love that. Then I can again safely skip penetration, so if I equal 0 and j equal 0, simply continue. Then let's define our offset. Then instead of reading depth, let's read normals. So float 3 normals n equal sample scene normal with screen UV plus offset. And now here I have a problem because I simply can't add the normal values on top of my gradient value because normals are float 3 while our horizontal gradient is float. So what I'm going to do is I'm going to use the dot product between this normal and normal for our current pixel. So before the loop, let's go float 3 cn for current normal equals, again, sample scene normals screen UV. Then here I will go float dp dot product equals dot of cn and n. And now I can again go gx plus equals dp multiply our horizontal kernel, and for gy our dp multiply our vertical kernel. Then again outside the loop, let's calculate our gradient. So float g equals square root of gx square plus gy square, and then same thing, outlines equals step with 0.02 ng, and this time let's change this threshold value to 2. And again, to fix these errors, I have to go hash if defined. Then for this one, I have to go unity declare normals texture included. And then I have to go hash and if. Then let's also initialize our outlines with 0, so like that. Then let me copy this function name and let's head over to Unity. In our shader, I'm going to duplicate this custom function node, and this time I'm going to use normal based outlines function. So we have a nice custom function for normal based outlines as well. Let's visualize that. So now we have nice normal based outlines, and it fixed a lot of issue with the depth, but it also introduced another issue. So here I have a plank floor and this is the bed. If I look at it from this angle, here I don't get outline at the edge of the bed because this plank normals is pointing straight up and this bed normals are also pointing straight up. So both of them are exactly parallel, so there is no angle difference between them. Hence, I'm not getting this outlines. So you can see that both this technique have its pros and cons, like almost every other thing in graphics programming. So to tackle this issue, let's combine both these outlines. So what I want is, I want the depth-based outlines where I'm not getting the normal-based outlines. So for that, I'm going to use this normal based outlines and go 1 minus. It will just invert the values. So let's just visualize it. So now I have value of white where the normal based outline doesn't exist. And then I'm simply going to take its output and multiply it with the depth-based outlines. So here I will have depth-based outlines only where there is no normal-based outlines. Let's just visualize that. So now you can see that here I have depth-based outlines and here and here. Then let's add this on top of our normal-based outlines. So simply go add it with this. And now we have nice outlines. Now I also want to control the color of this outline, so I'm going to create another property, color. Let me call it outline color. And I messed up the spelling again. Let's default it to black, drag it in, and multiply it with our outlines. Take its output and use it in the base color block. So now I have black outlines, which we can't see currently. And now I obviously want to see the actual scene as well. So I'll simply use the alpha with the swizzle node and use it in the alpha slot. And now, as you can see, we have nice outlines, which I can control from the inspector. And I can also control the alpha or opacity. Pretty cool. And this outline will work in more complex scene like this one as well. Now, obviously, like every technique, there are some drawbacks. First being that you can't go crazy with the outline thickness. So let me just show you. Let's set the slider range to 30. And then if I go put in some big thickness, you can see that our effect is breaking apart. So you have to be mindful of that. The second drawback is this technique is expensive because let's head back to our code. So here you can see that we are sampling full screen textures for like multiple times. 8 and 8, 16 and 17 times in total. So that's bad. Then the third drawback is this approach won't work with transparent objects. And I'm sure I will get questions about, is there any way to omit the objects from the outlines? Well, I could try with render queue, but honestly speaking, I don't think there's any easy way to omit the particular objects with this full screen approach. For that, you probably have to go back to per material or per object outlines with like inverted hull method, which I also have a video about it, and I might rework that in the future as well. Let me know in the comments. Hopefully you find this video helpful. If you do, hit that like button, and if you haven't already, please consider subscribing. It would massively help me secure potential sponsor deals in the future. Also, you can get the project files from my Patreon. That's it from me, and I'll see you in the next one.